Hello, my name is Jeffrey Rosario, and I will give a presentation on the cervical cancer risk classification. Now, what is the problem statement? Now, a hospital X, has contacted company Y for a machine learning, has learned about data science, and they want a machine learning algorithm that can help them to identify the risk for cervical cancer, or whether they should perform a biopsy, rather. Now, the goal is to find and determine whether the patient needs a biopsy or not. A biopsy is done after several tests are done, such as a pap smear or a Hinzelman test. We would also like to see if there is anything that can be recommended to patients by their doctors to avoid needing a biopsy. Now, what is the business value? For a hospital, you can avoid malpractice lawsuits. Nonfeasance is the failure to perform an act that is a professional duty. Medical malpractice falls under this category. Also, hospitals make more money on surgical patients than they do medical patients. If more biopsies are detected as needed, we can also increase the revenue of the hospital. Now, what is the methodology? What did we use? We used a 2017 cervical cancer risk classification dataset gathered from Venezuela. This contained about 900 rows of data, or patients. Several models were performed, and the logistic regression proved to be the best. We will focus on this model for this presentation. Some of the dataset had missing values, and we dealt with the missing values with data imputation of the mode for categorical variables and the median for continuous variables. Finally, we used the recall score, which is to say how many false negatives were avoided. So the higher the recall score, the less amount of people who needed a biopsy did not receive one. So after the logistic regression, we wanted to see what features are important, right? And according to the logistic regression, these are the top 5 features: whether someone has used hormonal contraceptives, the diagnosis of cervical intraepithelial neoplasia, and the three tests performed prior to a biopsy test is given, which is the Hinzelman test, the Schiller test, and the cytology test. Now, let's look at the model accuracy. Let's see whether the logistic regression was accurate. On the left, we have the confusion matrix, right? The bottom right shows that 16 of the 16 people that had a biopsy were predicted to have a biopsy done, illustrating a 100% accuracy on positive cases, as you can see on the right graph, indicated by the 1 on the predicted, which is shaded dark blue. What this highlights is the lack of false negatives, which is what we focused on. In this case, we want a higher recall score. We don't want to miss people who actually need a biopsy to not get one. So this is great. Now, what are our findings? The best model performed at the highest level of accuracy possible. The most important score we want to look at is the recall score. A score of 1 or 100% means that there were no false negatives. So the first row with the 0 is not as important as the second row with the 1, because if a person needed a biopsy, did not need a biopsy and they did receive a biopsy, it's not as bad as a person who needed a biopsy and did not get a biopsy. So that's why we focused on the second row and the third column, which is the recall 1. If the model were fooled by false negatives, this can risk the life of a person. And as you can see, we only had about 16 positive cases and 268 negative cases. Now let's see some of the statistics behind the positive and negative biopsy cases. Detailed in the chart are the mean results of all the patients for each column. Notable columns are the amount of time they have been smoking, how long they have used hormonal contraceptives, IUD, and the amount of STDs had. If you take a look, you can see nearly all columns showed a doubled amount. As you can see with the IUD, the amount of years 0.49 to 0.75. Smoking had a twice as much incidence rate on the positive cases. Now, disclaimer, just because it correlates doesn't mean it's actually true. There does need to be more research on this. Now, my recommendations are we use this logistic regression model to determine whether a biopsy is necessary. Doctors can input the patient data into this model, and they can determine and help whether the patient needs a biopsy. Also, the doctor can advise patients of the hospital to stop smoking, IUD, and hormonal contraceptives, and instead use condoms to prevent the incidence of STDs and pregnancy as an alternative to hormonal contraceptives and IUDs. Now, the future work we do need a bigger data set. The data set is pretty small. Also, the data set was in Venezuela. We would like a different location, maybe the United States. And also, we would like to search a few different hyperparameters for other machine learning algorithms. Thank you very much for listening. Goodbye.